All right, good evening, everyone. Thank you for joining us. Uh, my name is Blake Blaze. I'm kind of the jack of all trades at Data Classroom. I'll be acting as the MC tonight, joined by founder and CEO Aaron Reedy. But for once, for a change, we are just going to be in the background. We're joined tonight by three fantastic panelists, whom I'll introduce in just a moment. But first, I want to go over a quick agenda for the evening. So the theme is, this is how I use Data Classroom. And we're going to have three Data Classroom super users go through a quick presentation about how they've used Data Classroom with their students. We'll have a quick Q&A session after each individual presenter, and that's the opportunity for the audience to ask any questions specific to their presentation. And then we'll also have a Q&A after all three have finished their presentations for more general questions about teaching with data and how to use Data Classroom. So without further ado, I'd like to introduce first Dr. Andrea Peoples-Marwa, who is the Science Department Chair at Merman School in Los Angeles, California. She teaches 6th grade planetary science and 8th grade physical sciences. She has 31 years teaching experience, including science fair competitions on county, state, national, and international levels. We're also joined by Brian Johnson, who earned his undergraduate degree in biology and education from Lenore-Rhine University and a master's degree in biology from UNC Charlotte. This is his 24th year teaching and is currently a high school biology and research teacher. In the fall of 2021, he started a multi-year science research program at his high school and has had some pretty incredible success, even sending students to the International Science Engineering Fair. Bob Kuhn is currently a biotechnology teacher at Innovation Academy STEM High School in Alpharetta, Georgia. Go Dogs. He teaches introductory and advanced biotech. He taught AP and honors biology for over 20 years. He's also the sponsor and creator of DNA Club, a biology research club going on its 5th year with over 40 students doing advanced biology research. Thank you, the three of you, for joining us tonight. And without further ado, Andrea, I'd like to turn it over to you.
Yes, thank you so much. Good evening, everybody. It's so nice to see you and meet you here this evening to discuss Data Classroom. I have to say that Data Classroom is a wonderful platform for students, especially those students that have an interest in research. What I found for Data Classroom is that it is truly embedded in data literacy, research literacy and science literacy and NGSS standards. And that's something that I think about whenever I present Data Classroom to my students. Now, while I don't have a presentation to share with you, what I would like to do is share a screen and show you how I navigate Data Classroom. So here is my account. And as you can see with Data Classroom, there are many. I'm just going to pull you all up here so I can get to the other side of my screen. You can see that there is a research library where if you put the pointer on that and click on it, you have pages among pages of various research topics, ongoing research that stems or varies from biology to physics to even current events. And what I like to do is to align the Data Classroom lessons, the research lessons, with what it is that I'm teaching. And sometimes I don't align it. People or my students actually will log on to their own accounts and they'll see something quite interesting. For example, timing the swing of classic pendulum activity. And even though they might not have had that lesson or they might not understand the pendulum activity, they are still wanting to learn more about it. And what I do is I open up the lesson plan. You do have lesson plans where you can open up and the lesson plan is available for you with a fun graphic. And sometimes there's more than one fun graphic. You will find that there are videos that you can also play for your students to help them understand the lesson more. But the most important thing here, everyone, is data and allowing students to feel very comfortable with data, understanding data analysis, as that's very important. Another cool thing about Data Classroom is if you get into statistics with your students, as I do, and I start them very young, I teach them about p-values, teach them about chi-square testing, t-testing, chi-square for categorical data, t-testing for numerical data. What I like to do is show them how different tests can be applicable to the data sets and really allow the student to think about more so inductively, rather deductively, about the analysis of the data. Why does the data appear to be in the way that it is? So it's a wonderful, wonderful platform that keeps students' interest. I'm going to go back and show you something else. let's see, go to the resource library. Is it going to let me do that? Let's go here. Okay, you can see the grades. There's any grade up to 6th, 7th, 8th, 9th, 10th, 11th, 12th, and college level. So however you want to best challenge your students, or if you want to keep it within the grade frame of reference, you can do that. But it's such a wonderful platform where I've gotten nothing but positive feedback from my students and from the families. I've even brought along my co-teacher who teaches 5th grade and 7th grade. Now, the 7th grade students she has were my kids last year, so they were all trained in DataClassroom, but the 5th graders are absolutely loving it. And we're trying to get the lower school on board, as our school is separated with between lower school for the primary grades and upper school for the intermediate grades. But it is a wonderful platform. Once you join and you become a member, just take the time to navigate. It's so very important to navigate so that you understand how to share the data sets. So let me see if I can show you something here. Let's go back to this one. Let me move you up. Excuse me one second. Let's see if I open data set. If you go here to what I call the hamburger, the 3 stack of lines right here, you can share this with a class. So for example, I have my A Marwa. This is my 6th grade section A, B, and C, and this is my 8th grade section A and B. If I wanted to share something with them, I can click on that and share a copy. And the title shows Timing the Swing, a classic pendulum activity, and I can save that. So right now, all of my students are able to check their email and probably wondering, why are we doing this right now? But I'll just tell them it was just to show as an example. But what I'm saying is that you can share all of this information with your students. It's quite easy. It tells you, if you look at this page right here, you can see how to import data, even for science fairs. I'm really active with science fair competitions. Students are able to take their data and import their data into DataClassroom so that they can see, if any, what statistical analyses or statistical tests are applicable to their data set. You can easily graph. If you click on graph, you can easily graph, and graph-driven tests are right here. So it's a wonderful, wonderful, wonderful tool, wonderful resource for getting your students to become very much so data literate, science literate, and research-driven, research literate. If you have any questions at the conclusion of this meeting, I'd be more than happy to answer those questions. Oh, and by the way, if you're not strong in statistics, or if you're not strong in data, there are some parts of data that I'm more strong in versus others. That's okay. Aaron and Blake will tell you I've emailed them quite a bit with questions along the way, and they're very open to taking your questions as well. And I'm hoping to connect with everyone. I will leave my information in the chat, my email, and I look forward to working with you and to joining forces and to helping our students with becoming more involved with research and data and statistics and all those fun things that go along with it. Thank you.
Thank you, Andrea. Before we turn it over to Bob, I have a quick question for you, if you don't mind. And that
Yes.
is, would you mind sharing what some of your conversations are with your students concerning a p-value? Like, we find that that's a really complicated and sophisticated topic, even for high schoolers and sometimes college students. And such, I think it's really impressive that you can introduce that at such a young age.
I do. I always tell them that the letter P stands for probability. And one of the things that we talk about with p-values is when we're dealing with chi-square or for categorical data, your p-value, scientists are happy if that p-value is less than 0.05. That means that there's some significance, there's a correlation with your variables. If your p-value is greater than 0.05, sometimes scientists are not very happy with that. And what that means is that there isn't any significance or any correlation between your variables. And I start them off with, I have a 3 set series. We're just finishing up step 2 today, showing students how to figure out p-values and how they're applicable to chi-square testing. And now that my kids know how to do that and understand it, they're calculating these p-values. There is a chi-square calculator, though, I will say that. A chi-square calculator where the students are like, oh my gosh, Dr. Peoples-Marwa, this p-value for this is less than 0.05. Therefore, everybody's happy. And so that's how I teach them, especially with the younger groups, because it can be quite confusing for the young and the young at heart.
Yeah, and I have a follow-up question for you, Andrea, too, is like what would you say to people who say, you know, like data, that's something that's complex, that's just for older kids, but you've obviously had you know, a pretty good degree of success working with data and younger students in the middle grades, and you mentioned a colleague and who's working with them in 5th grade. Like what would you say to people who say, you know, young kids aren't ready to work with data yet?
Oh, they're ready. Young kids are always ready. They always have those questions. Don't be afraid. Don't be afraid. If you're afraid of data and if you run from it, your kids are going to pick up on that and they'll run too. Just, you know, tell them that there's only 4 things you can do to numbers. You can either add them, subtract them, multiply, or divide. That's it. And when you tell them out of the millions of things you can do in the world, those are the only 4 things you can do to numbers, they're like, oh yeah, that's right. So tell them or remind them not to be afraid of data. I used to be afraid of data. It was up until I was in grad school when I had to do all of this stuff by hand. We didn't have all of this. I wish we had this. So thank you, Aaron and Blake, for introducing Data Classroom to students of this generation, something that I truly needed. Where were you guys when I was going through all of this? But don't be afraid of data. They're just numbers. Numbers don't bite. They'll make you think. And it's really interesting when you're able to find out what that data is simply saying. So is it completely by random that things happen in the way that they happen? Or is there something much more interesting about those numbers that you want to convey to everyone?
I love that.
I want to put numbers don't bite, but they'll make you think. I want to like put that on a t-shirt or stickers or something.
Well,
Are there any other questions?
I'm not seeing any in the chat for now, but thank you, Andrea.
My pleasure. I'll go ahead and put my information in the chat.
All right, Bob, can I turn it over to you?
To me or to Bob?
To Bob.
Okay.
Sorry about that. I thought you said Brian. One sec. All right. Can you see my black screen there? All right. So my name is Bob Kuhn. I teach at a STEM school, high school, just north of Atlanta in Alpharetta, Georgia. It's a STEM magnet school, so very different from where I taught just a year ago, which was a non-STEM public high school. But I use Data Classroom in both schools, and I'll focus on just a couple things that I really like about Data Classroom. It's my go-to data visualizer and statistics platform, not only for my classes, but for kids doing research as well. I think the thing that drew me to it initially was one of the biggest issues I had with students was the length of time it took to collect data and eventually lead to a visualization of the data that they could discuss. Normally we had students who had, maybe they had Excel, but they had different versions. I had to teach them how to make a graph in Excel, maybe formulas, and we spent more time learning that platform than we really did with data visualization, and they were pretty fatigued before we got there. So with Data Classroom, literally in 15 minutes, we can be discussing a visual reference of the data and get into the guts of what's going on. And I'll give you an example. This is just such an easy activity that a lot of biology or maybe even chemistry folks do. Just water or alcohol drops on a penny for demonstration of surface tension. And so this was something I have the kids I have all the kids in DataClassroom as a class to begin with, so it's very easy for them to get on and go right to their part of the data input. And they were doing multiple trials of water or alcohol on a penny for surface tension. They were able to graph their data within 10 or 15 minutes, and we could be discussing it as a class. And very clear, easy way to focus the majority on the class on the phenomena itself, and not having to worry about creating the visualization. There's some statistics here with the honors kids. We do basically measure central tendency and maybe standard deviation. These are SEM bars, which we did get into a little bit, but that's something we're trying to change at the STEM school, and this is going to really help us transition. In fact, our school is a DataClassroom school. We just purchased a school license, so I'm very excited to introduce that to the rest of the faculty. Also, in my biotech class, very similar, we were measuring, so we were looking at cell damage on beet membrane cells, so the vegetable, the red beetroot. And so we were subjecting the beetroot to alcohol or acetone, depending on the experiment. And they were going to measure the cell damage based on the light spectrophotometer, using that to estimate the amount of damage based on how much beta cyanin was released. And before we could do that, we have to do a standard or a absorption spectrum to establish where the best wavelength of light is to set the machine. And so they had, as groups, they had different measurements they had to make. And as they were making their measurements, they were putting it into the platform and building their own absorption spectrum. And, it was very clear and easy for them to use this. And this then allowed them to have discussions and then move on with the rest of their experiment, which was testing their experimental treatment. So just a very quick way of getting to data and using the data. For AP Bio and some of the other classes, we use data visualization with DataClassroom to start the year off with statistics. So very quick, I guess, this is a AP Bio lab that I've been doing for probably 6 or 7 years. And one of the things that's awesome about a graph like this for the students with DataClassroom is there are no bars to hide anything behind. You can see all of the data points. You can see the spread of the data, even without any statistics. Kids can see the points. They're very clear. They can manipulate them with their size or whatever to visualize them, but you can have great discussions about the way the data is distributed, even without getting into statistics. Likewise, we can do, for AP, one of our skills is t-tests. So it's very easy to do a t-test for this straight from the graph and talk about p-values and t-scores and things like that. For honors, we do a very similar thing with root nodulation with rhizobia. And here they're changing variables, but and this is over 5 years of the classes doing the samples. This is a cumulative data set, but they can see that nice spread of data. They can see the data trends. They are kind of provoked to tell me what they think the trends are, and it's just very clear. And for this, we can get into some advanced statistics that we normally would never touch in high school, at least in my experience, things like ANOVA and the Tukey's range test, which I love because this was added because you can see relationships between different parts of the graph, and that makes it very meaningful to the students. We also, in our research club, DNA club, we do poster production and some publishing, and DataClassroom is perfect for that. The quality of the graphs that you can make are great, and they fit right into something very visual like a poster. And you know, these are some examples that we've used over the years for different kinds of data figures on our posters, and these were all created through DataClassroom. So just a cross section of ways that I use it, and I'm happy to take any questions if anybody has any. If I can figure out how to unshare. Can someone do it for me, or do I have to do it?
I think to unshare, or maybe Blake can take it back, but I have a question for you, Bob, and I think that it was cool to see that that screen you put up that had like 4 different graphs from pretty varied projects, and it really made me think about how challenging that must have been as a teacher to handle guiding students through so many different analyses. You clearly are giving your students a lot of freedom to develop their own projects and things. And how do you handle that, mentoring students through so many different kinds of projects and ultimately so many different kinds of graphs and statistics?
Well, it is a lot of herding cats, but we have a weekend so that the students are asked to poke around on DataClassroom, and once they get the data in there, to experiment a little bit with the different ways that they can choose categorical and numerical data. Think about, we have an organization chart that kind of steers them through like a flow chart, what statistical method might be good, what kind of graph might be good to use. And then we have a big weekend where we're together in teams, and we have discussions about the data and what might be the best way to visualize it based on what point they're trying to get across. So they're not experts. I mean, I'm not a total expert either, but these conversations are great, and we reach a point to where it may not be perfect, but we think, you know, okay, this is maybe the best way to show this. So
I like that you mentioned that you have like flow charts and graphic organizers for statistical tests, because that is exactly, you know, how I got through statistics in graduate school and in my PhD training. So it's I think it's a method that can work at a lot of different grade levels, and it's actually some of the kinds of things we've tried to build into the software is that same kind of logic, because it works.
Yeah, and actually that flowchart portion of the platform I use a lot with my honors intro kids as well as AP kids, to let them decide what they think might be the best way for data analysis. So that's been a great thing, letting them make decisions and come up with reasons for why they chose what they did.
Great. Well, Bob, your presentation gave me a question, but I think I'm going to save it for the group at the end. Thank you. All right, Brian, will you take us home?
Sure. Let me go ahead and I'll share presentation here. All right. Thank you, everybody, for joining us this evening on this National Championship Monday, right, Bob? And so I wanted to just share a few things that I've done in the classroom. Like Blake said at the beginning, I teach high school, mainly high school biology, but here recently over the past year, we've started a research methods class at our school, or I should say program at our school, that has multi levels for the research program. And so that's when I really started to use DataClassroom and when I was introduced to it. However, what I found out was that very quickly I realized how I could be using this in my other classes. And so like what Bob was talking about, I'll piggyback off of some of his experiences because they're very similar to mine. I realized how much easier it made students or allowed students to be able to analyze data in a particular lab. So this is one of our students, Blake mentioned. She was our student last year. She used DataClassroom. She ended up going to the International Science Fair last year with her project. And I'll talk about that project and how she was able to analyze her data here in just a second. But in the Research 1 class, what we do is students go ahead and propose a project that they're going to work on later on in their high school career. And so they do a lot of background research. But one of the coolest things that I found last year when I was working with my Research 1 students, and here's just a couple of them, they were able to go ahead and down where the boxes are, they started to predict their results. So they could go ahead and say, this is what I want to do. I don't have any data yet, but let me go ahead and predict some of these results. And so after we had introduced them to DataClassroom and they had used it on a couple of other projects, they were able to go in and start making up data and looking at the visual representations of that so that they could think ahead about what they might get as results of their longer term experiment. And the first time that it happened, the girl in the lower left, she's like, oh my gosh, I can use DataClassroom. And she just starts typing away and she's like, whoa, the graph would look like, and she's talking about what types of data she would get, what types of tests that she could run with it, what it's going to look like, what it's going to mean. And so the ability of students to be able to think about data in that way. Like Bob said, I spent countless hours teaching kids how to work Excel or Google Sheets to make graphs. And we would spend a class period sometimes just trying to get a graph, because if you're like me, my students would just take all the numbers and hit the graph button and see what popped up, and that must be good enough. Let's turn that in. And so there wasn't really any thought about the data at all. It was just, let me get all the numbers down and hit that little graph button, and then I'm done with the lab. And so if that's all your students are doing, there's really no thought involved with that particular lab. They're just pushing buttons and moving on. With DataClassroom, what it does, though, is it allows us to be able to look at the data a little bit differently. So this is another one of those biology labs, a little osmosis lab, where we take potato cores and we put them in different concentrations of salt to see, we weigh them, get different masses, and do percent change of mass. And so this is just a regression line. And what it allows us to do is determine what's known as the isotonic point of those potatoes. So yes, we can see which ones are gaining weight, which ones are losing weight, but the ones where we don't see any change at all is going to be the isotonic point. And so we can see these. We can also find the slope of that line through DataClassroom pretty easily. It's totally customizable. Students can see those relationships really easy. And what I like about it is once that data is organized, you really can't graph it wrong, right? Because if you try to graph it wrong, then it's going to send warnings at you saying, nope, you can't do this. You need to have, two types of numerical data if you want to do a regression, or if you want to look at it a different way, you have to have categorical and numerical. And so the students are going back and they're looking, well, is this really categorical? And sometimes they realize that depending on their data, it could either be categorical or it could be numerical, just depending on how they want to graph that. And that could change the ways that they do that. And so this allows not only my research students, but now my biology students to be able to look at their labs a little bit differently, because we're focused more on what the data is telling us than actually doing a bunch of math. And since my math teaching partners are not here with me, I feel free to say this, but I could care less if my students can actually do the math for the statistics, because it's a science course, right? Let the computer do that work for you. And I tell them, if you want to learn how to do the math to figure these out, then take statistics down the hallway. He'll go through all those different steps. But this is a way that we can understand variability in data. We can look at the spread of that data. They can start to understand some of these standard deviations and things like that. And so going back to my student in her project last year, these are very similar to the graphs that Bob showed, but this is her actual data that she presented at the International Science Fair last year. And she was looking at how rider movements in a hippotherapy session. So hippotherapy is just using horses for therapy for people who have disabilities. They come to the farm and they ride horses. It's a form of physical therapy. And so she worked at one of these barns, and what she was looking at was how the different movements of those riders, of the patients, impacted the horses. And so she was looking at stress behaviors in horses. And what she noticed was when riders would go over or when they would get on the horse, they would mount the horse. And when they would reach side to side, putting rings on this little post, she saw more of those stress behaviors. And here you can see that visualized very well, that we have both the rings and the mount that look very similar to each other. So what's different between those and the bridge? Well, the bridge, you're just sitting upright and you're just moving forward and backward. With the horse, you're not moving side to side. And so she was able to use this to figure out that lateral movements were impacting the horse more than just the forward to back movements. And so she was able to group the data in a way after she did her ANOVA here. Again, high school students, I wasn't doing ANOVAs until grad school. So, a high school student using an ANOVA to figure that out, that there was a relationship between those. She was able to group the data into lateral and non-lateral movements and be able to look at them that way and compare them. And so it really helped in the visualization, but not only the visualization, but then for her to be able to come up with some sort of conclusion about what that data is saying. My advisor, when I was doing research, my advisor always told me that the data is the data. It's trying to tell us a story, and our job is to figure out what that story is, right? And we use things like statistics to be able to answer those stories or to figure out what that story is. But I always like it because I feel like a detective when I get all these numbers and I'm trying to figure out what that story is. And what's great and what struck me when I first saw this particular program that's made it so useful for me is just the ability to visualize that data. The ability to be able to look at these error bars, even if a student doesn't have any background in statistics at all. They can look at error bars and they can see, is the data spread out or is it, clumped close together? So, and how that correlates to that error, right? And the more that they see that, the more they start to make that connection. So now they may not need error bars. They may be able to see groups of data and just intuitively kind of know if there's a lot of deviation or if there's not a lot of deviation. I don't have any pictures of it because it happened so recently, but right at the end of the last semester before Christmas, one of the things that we do a symposium. It's kind of like a little science fair at our school, and my students present, but we had built an app for those students. And so everybody who attended this symposium could pull their project up on the app and they could rate the student as they were given their little 5-minute poster presentation on the app. The great thing was we could take all of that data, and I shared all that data with them, went right into DataClassroom. They were able to look at the different categories, how they were rated, and they could look at that standard deviation and they could see how spread out that data was. They knew that if they were getting a score of a 4 and there was really small deviation, they knew that everybody was agreeing that they were a 4 in that particular section. But if they looked at another section and they had a huge deviation, they knew that people weren't really agreeing, that some people thought they did a really good job, but some people thought they did a poor job. And so we started talking about confidence in the data. And well, which one do you think you did really well on? Well, I have a lot of confidence in this one because everybody agreed on it. Over here, they weren't in that much agreement. And so they did a whole reflection piece on that using the data that they had gotten from those presentations. And that ability to visualize it, though, just makes it so much easier for students to be able to make sense of what those numbers are. And I've realized that my students don't just hit a button and give me this graph that they can't even read themselves. It does force them, they don't bite, but it does force them to think about that data a little bit more.
Brian, I don't have any questions. I just wish I could have taken your research class when I was in high school, but we do have a question from the audience. Chris wanted to know, how did Hannah define the SDIB, or did she have a standard measure?
Yeah, so she actually worked with a professor at Rutgers University, and so the stress indicating behaviors, stress discomfort indicating behaviors that she measured, those were actually from published research that had been done. There was a whole list of, I want to say, 30 some different behaviors in a particular ethogram, which is just a list of behaviors. And she developed her ethogram based on those behaviors. And so she chose 5 different ones to be able to analyze.
And correct me if I'm wrong, I think that the Rutgers professor helped her find a software that was able to analyze videotapes.
Right. Yeah, she used the same software that that this professor's grad students used when they were looking at stress in equines in equestrian college. Right. I've learned more about horses over the past year than I thought I'd ever learn. So.
And I just love that she was doing work that postgrads were doing in high school.
Right.
And Brian, to kind of to piggyback on that, you mentioned something that your students started doing where they were making dummy data sets to show what the data would look like if their hypothesis turned out to be supported or not supported. So they were sort of like making predictions in advance and saying, not only this is what I predict for the hypothesis, but this is exactly what my figure will look like. And I got to say, that is what my PhD committee made me do with any idea I ever proposed. They said, well, what will it look like if your hypothesis is supported? What will it look like if it's not supported? So that is like a tried and true method that your students will use as they advance. It's just really cool that they sort of independently came to that.
Well, they did, and I can't take credit for that because that was something that particular student, and now it's like I encouraged them to do it, right? But she was like, hey, I could put this in and I could just, make some graphs to see what it would look like. And to her, that helped her process the information a little bit better. And so I thought it was a fantastic idea. Not only that she came up with graphs that would support the hypothesis, like you said, but then also graphs that would disprove the hypothesis.
Mm-hmm. And you kind of know if you have a good experiment, if at the end of that exercise there's really only kind of 2 outcomes, like supported and not supported, or if you realize that there's sort of something else in there, sometimes that can help you refine your design to.
Exactly. And that gets into thinking about, okay, what types of data will I collect? What do my methods look like? Do I need to change the methods at all? So these are the only variables that I'm getting. And yeah, it really does help them work through that process.
Yeah.
Thank you, Brian. We'll open it up now for a short Q&A for all 3 panelists. I have 1 or 2 questions that were emailed by people who couldn't attend tonight, but I do want to give everyone who's here now a chance to ask a question for Brian, Andrea, or Bob, or all 3.
And if we're waiting for questions, I have one I could put to the panel. In working with a lot of different schools at a lot of different levels and teaching a lot of different courses, I'm interested what the 3 of you would say to just the sort of criticism, and I'm going to play devil's advocate here a little bit, but I have heard things along these lines to say, oh, well, we can't teach kids how to work with data in a digital tool because they should be learning how to draw graphs by hand. They should be learning how to do it by hand, because if you really want to know how to do it, you got to learn to do it by hand. And if they work with a digital tool, you're sort of taking that opportunity away from them. Well, I'm curious how any of the 3 of you would respond to that.
I have to say statistics is statistics, data is data, whether you're doing it by hand or whether you're doing it via computer. I think that when students find themselves involved in understanding graphs and the stories that they tell, regardless of if they're doing it by hand or on computer, they're still learning about the data set, and you really can't get away around that. The statistics that the students learn through DataClassroom is definitely helping them to draw conclusions about the data that they're particularly working with, depending upon the the research that they're choosing to investigate on DataClassroom. So for me, the way I approach that is it doesn't matter. They're still going to learn.
For me, I would say, show me a profession where someone grafts things by hand. I don't think that they exist. But I think that regardless of the platform that's used, if the students can learn the appropriate way to analyze data and the appropriate way to look at a graph and to be able to make sense out of what it's saying, then that transitions into whatever platform you want to use.
I don't think there's anything wrong with doing graphs by hand. I think you can do both. We do a lot of whiteboard modeling and things like that, or just rough sketches of kind of what y'all were saying before about what we think the data might look like. But I think the discussion ramps up a notch when you can put it into a visualization and analysis platform like DataClassroom. There was really a lot you can do very quickly to kind of get to details that it would take a long time or if you were making multiple hand written graphs. So I just think perhaps doing graphs by hand is a skill, but I think you gain a lot more by the versatility of what you can do on a platform like DataClassroom very quickly. So I don't think there's anything wrong with graphs by hand, but with the age we're in right now, I think a lot of digital visualization is a lot more efficient.
Thanks for that. I enjoyed all those answers. I have another question for the panel. And this is maybe not necessarily a DataClassroom question, but just something I think about a lot. And the question is, where do you start when asking students to use data to answer questions in a scientific context? In each of the classes that you teach, where is your starting point, and how do you introduce that as a concept to students of using data to answer a question? I fully acknowledge, hopefully they've been introduced to that before in other classes, but how do you do it in your class?
I have students create their own scientific questions, their own investigations. And as a matter of fact, that's a part of what we do for our science fair research area. Students will, and I tell them, use your observation skills. Think of something that you've always wanted to find the answer to. And if you can create a question that's testable, then go from there. We go through the scientific process, scientific inquiry, and from that point, students are able to devise their own questions that are testable, of course, and then they begin to think about the data. What would the data look like? So I allow them that opportunity to be able to play with that. And from that point, they're able to come up with these wonderful ideas and testable questions. And with those testable questions, they enter science fairs and do quite well with it. But that's where we start. We start right there at the very beginning of the school year with coming up with their own testable question on something that they've always wanted an answer to, and they come up with what the data may look like.
For me, I go ahead and I start all the classes off that we're using DataClassroom. I usually start them off simple. If it's in my research classes, regardless of the level, I'm going to start them off with some different activities that we can do just to get them familiar with the program or remind them of the program. If they've already used it before, it usually doesn't take that long. But again, it just introduces them to the different types of statistical tests that they could possibly run. I think having kind of like the flow chart that we were talking about earlier, I think for them to have a general understanding of what is possible and what they can use is beneficial to them, and when they start to develop their research topics and ideas.
Okay. We've got some questions coming in from the audience here. I'm gonna take one, which was how difficult is this to integrate into what you already do?
For me, it's just a simple substitution. I was using Excel before, and I can still assign, if I want them to do that, they're more familiar with Excel, they can still put it there and import that data directly into DataClassroom for the visualization of it. And so it has been very seamless for me.
I use it as a supplementary to what I currently do in the classroom. It's not difficult at all. It's quite a smooth transition. So whatever it is that I'm teaching for the moment, I will find something, if I'm using something in alignment from DataClassroom, find a data set that correlates to that. If not, I might just show them anything just to get them used to feeling comfortable with data and visualizing data.
Yeah, I think having the classes set up already in DataClassroom and ready to go was very helpful because we didn't have to worry a lot with how to log in and these kinds of things. I would say, I guess, the only slight shift in thinking was the tidy data organization, going from data tables that they've been conditioned to make over the years to a different way of organizing and thinking about data. That in itself was a very valuable, half a period lesson on how to organize. And then we just collected data in that style from thereafter. So it was pretty seamless, and students just were able to transition pretty quickly to working with it that way.
I want to add on there too that we use it weekly. So it can be Monday, Tuesday, Wednesday, Thursday, Friday, or what have you. There is one day out of the week where we call it DataClassroom and DataClassroom interface. And I write everything down on my whiteboard, what we're going to do for the week. And when the students see, oh, it's DataClassroom interface day, typically it's the middle of the week that we do that, but we do it weekly. There were some times where we didn't get around to it during the week because of other events happening at school or whatnot, assemblies, but otherwise it's held. We use DataClassroom weekly.
And just to piggyback off what Bob was saying, with the tidy, even if you want to integrate it in one way, I would suggest looking at the information that is on the DataClassroom website and their blog about tidy tables. Because what I found out was that it really helps students to identify their variables. They can't make a table that way if they don't know what their variables are. And so it's a great way for them to see if there's variables there that they don't necessarily need. And it's a different way for them to think about the data and to organize it.
For Bob and for Brian, then how to kind of answer that question for the audience, how often do you incorporate DataClassroom into lessons?
For me, it's mostly when we're doing labs. For my in-class subjects for my club, we're using it towards as we're collecting data from experiments, we're putting it in and fooling around with it and seeing what we see. But for my honors bio and when I taught AP bio, it was AP bio. We did a lot of it at the beginning of the year where I was really intro statistics focused. Then as we did labs throughout the year, we would come back to it every time we did a lab. Honors kind of the same way, except for there are periods of time in the honors class where we'll bring it out quickly to illustrate some things in class. We're not really doing a lab, but we may have a data set that we're working with. And we do that quite often, especially when we get into evolution and things like that. There's a lot of nice data sets that we use to to bring some of those ideas home, because evolution is kind of a hard one to do lab with our time constraints. So
Bob, we had a follow-up question on your response from the audience. This is from Ryan Westbury down in Florida. And he was wondering, is biology non-AP a tested EOC subject in your state? So is it tied into your standardized testing in Georgia?
yeah, it is. We have an EOC in May, I guess. And it's definitely one of the 2 classes in science that kids have to graduate. So that and physics. So yeah, it's an EOC class.
And biology is an EOC class in North Carolina too. And yeah, same thing. What I found is that using the data and analyzing that data only helps the students do better on the test. I know that sometimes we get so focused on trying to make sure that we get through content that we forget, but it helps them to think about the content that they're learning about in class when we do those labs and activities. And it really does help students move past the trying to figure out the numbers and really being able to see what the numbers are saying.
Yeah. And then I think we have time for 1 or 2 more questions. This is another audience question. Have any of you had cross-curricular supports from your math colleagues in working, even if not specifically with DataClassroom, but working on this kind of data analysis stuff?
Unfortunately, I have not.
So as a STEM school, we're very I guess cross-curricular is a good term, but we have pathways of healthcare, IT, and engineering. So we have a lot of overlapping project-based things that we're doing, and so math is embedded and incorporated through that. So it's going to be really great to hoping to do some professional development at our school to really make sure the teachers know how to use DataClassroom, so we can get more of that crossways kind of going throughout the whole school.
So you're saying like there's a lot of opportunities for it there, but it's not necessarily happening now, but you're kind of hoping to lead the charge on that. Is that fair?
I think there's some math. The math is being shared not only with science stuff, but our economics class. Even we have research, like a research AP research, and our school research program. There's a lot of sharing there. But I think it could be better.
I know that for us, we used to work with our stats teacher quite a bit on different types of tests and how to do those tests. What we found is that DataClassroom kind of answers a lot of those questions for us now, so that we don't have quite as many. But I've already shared that information. The math department currently is not using it, but have started to share that information with our math teachers, especially our stats teacher, and letting him know just kind of how students can visualize. And that once you get into the stats and you start playing with it, I mean, you can drag things all over the place to see what a p-value would look like. The verbiage that's on there tells you exactly what that p-value means. And so some of my kids who have had stats in the past and then have exposure to DataClassroom, they say, that's what that means? Like, I never really understood it when I was in stats, and now, wait, it means, okay. And so being able to visualize it takes it from something that is very an abstract way of thinking and making it much more concrete for the students to be able to grasp.
Great.
Well, we're getting pretty close to 8 p.m. Central Time, which means it's 9 p.m. on the East Coast. Thank you to the audience for joining. Brian, thank you for doing this on the first day back to class. Andrea, thank you for hustling across traffic to be here. And Bob, thank you for interrupting the national championship game to spend some time with everyone. This is the best part of the job for me and Aaron. We make the tool, we hope it works, but to hear from you all about how you're using it is the reason we're doing it, and you're all using it in ways beyond how we could have imagined. So thank you for sharing your time with us, and we'll be in touch.
Yeah, thank you. Thank you so much.